And let's see. Okay, let's do rolly roll. Okay. Okay, Donnell.
Here.
Layla. John Chavala. Jasmine.
Here.
Jasmine.
Here.
Matthew Gonzalez.
Here.
Brandon.
Here.
Morella.
Here.
Jeshua.
Here.
Gracie.
Here.
Carlos.
Here.
Jose. Ethan Ramos.
Here.
Natalia Rodarte.
Here.
Jaylene.
Here.
Giovanna.
Here.
Taylor.
Here.
Jay.
Here.
Diana Takeo.
Here.
Jacob. Roberto.
Here.
Reggie.
Here.
Mariana.
Here.
Okay, here's how I've absent. Kayla and Jose. Kayla Bradley and Jose Orozco. Kayla Bradley. Jose Orozco. All right. Okay. So, yeah. All right. Let's see. Brandon, I can't see you. See, I have 21 here? Okay. There you are. Hey, Brandon. All right. So here's what we're doing today. We're doing assignment number 33, 5.5, 286, 3 through 49, every other odd. We're solving logs. Solving logs. Okay, so we're solving log equations. It's going to be awesome because check your understanding. Got a bunch of problems here. It's when it shows us when we can use logs at a practical time. I'll get out of the way so you guys can see what I have on the board. Can you see what I got there? Is my camera, is the whole frame in the camera? Let's see. Let's ask. I'll get out of the way. Morella, how's that look, Morella?
Looks good.
You can see the whole frame?
Could you maybe scoot it a little bit more like up, like the camera?
Yeah, let's try it. How's that?
Yeah, that's good.
All right, cool. Thank you for helping me out there. Okay. So weird.
Is it every other odd?
Yeah, every other odd. This is every other odd. You guys know what EVOO is? Extra virgin olive oil. Extra virgin olive oil. All right. Anyway, it's a cooking term. Extra virgin olive oil is supposed to be really mild. It's got a good taste, right? Extra virgin olive oil means like they press the olives. It's the first press. It's like the freshest of the oils. So whenever you cook like Italian food, you want the EVOO. If you want to do less math problems, do the EOO, which is every other odd. Every other odd. Okay. Boop, 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 going to skip 3. We're going to go to 5. So you don't have to do 3. I should say 5 through 49 odd, but not 5. We're doing 7, right? That works. 7. Okay, let's go ahead and solve this. Look at this. 5 x minus 3 equals 25 x minus 5. Okay, so let's get a gander and write that down for a bit. Write it down, and I want to ask you guys a question before we solve this problem here. Okay, you ready? Let me ask you something. Jaylene, are you there?
Yeah,
Your camera's not working.
it says it's on my side. Like I can see myself on the top.
All I see is Harry. Is that his name?
Yeah, I could try to leave and rejoin because it happens when when I first join it shows, then it
Yeah,
says it's on.
but before you do, I want to ask you a question. Jaylene, see this right here?
Mm-hmm.
Using your intuition, what do you think x equals there?
2.
Yeah.
Power 2.
Wait, what? You changed
Power
your
2.
Yeah, so it just equals 2, right?
Yeah.
So with this, I can say x equals 2. Just using intuition, right? Okay, Jaylene, you can log on and log back on again if you want. Let's try to see if it works. But oh, now I can't see Jay. I can't see you either. That's weird. There you are. What happened? Is your camera off, Jay?
No, it's on for me.
Oh, it's so weird. There you are, Jaylene. Yeah, you joined us back. We didn't even go over anything, so I was so distracted. But going back to Jaylene said, hey, this is equal to 3. But right now, for my solution for this, I just write, all I need to know is x equals 2. I can just ignore the 3's, right? And I know since both of these are 3, then both of these have to be 2 in order for them to be equal, okay? That's the concept we have to understand here. If the bases are the same, we just ignore them and just set these equal to that. Now, my question is, are these bases the same? Go like this. Like this. All right. Yes, you guys are paying attention. They're not the same. 5 and 25. So what do you think I can make these without changing the value? This is a weird question. I don't think anyone is going to get this question when I ask it, but I'm just going to ask it. See if anyone can figure this out. What should my bases be? What should they be? And if you don't get it right, it's my fault, not yours. But someone just yell it out. If not, I'll just call on someone.
25,
Not 25. You would think 25, but that's not what I'm looking for.
50,
Well, that's not a good base. It has to be smaller. Smaller than 25.
15,
Less. I like this. But who going to give me a letter? Less. We're going to go with less. We're going to go.
5.
Yes. 5. Why 5? Does anyone know why? Can anyone tell me why it's 5? Anyone? Bueller. 25 can be 5 squared. I can't make, it doesn't change the value. This is still 25, right? If you make this 25, it's no longer 5. You want the same value, but this is still 25, right? So I can do that. It's still 25, just make it 5 squared, and then I go like this. Remember, this is 25 raised to the x minus 5. Okay, so go ahead and look at that for a second, see what I did, think about it. Think about what I did there. As you're thinking about it, I got a question for you. I got a question for Kayla. Kayla? Can you see that little green? My green's fading. Can you see that over there?
I just got on the Zoom. I missed like the first 10 minutes of your class because I was doing something.
Oh my gosh, you missed the greatest thing. I just told the best joke, but you missed out. Kayla, I'm still that you're here. I can't see you because your camera's off. But hey, what is this equal to?
I don't know.
X to the third raised to the second.
I can't
Okay.
see it. I can only see x to the third. Raised to the second is going to be x to the fifth.
No. Try again. There's my 2. There's my 3. X to the 3 raised to 2. See that better?
Yes, x to the sixth.
Yes, you multiply. You guys remember that? Who's that?
Yes.
Jasmine, are you there? Jasmine's blank. Jasmine. Jasmine's not there. Donnell, I can't even see you.
What happened?
I can't see you. How come you're just showing your window? Are you laying in bed or something? You sleeping?
Oh no, I'm on my couch.
There you go. Oh, I see it. Okay. Thank you so much. Okay, so Donnell, do you understand that 8 to the third raised to the second is 8 to the sixth? Does that make sense, Donnell?
Yeah.
Okay, so we multiply them if we raise them. Everyone understand that? So because this is raised to that, then I multiply 2 times x minus 5, right? 2 times x minus 5. So my question is, Reggie, what is 2 times x minus 5? I'll write it over here if you can't do it in your head. What is 2 times x minus 5?
2x minus 10.
Very good. Remember, this times this looks like this. You just distribute it. And I say 5 to the x minus 3 equals 5 to the 2x minus 10. Everyone look at that? Now, just like we had this, 3 to the x equals 3 to the 2, x equals 2. We just ignore the 3's. Just like here, I can now, since these are equal, okay, then I know that these must be equal. I can ignore the 5's and write this as x minus 3 equals 2x minus 10. That's how you solve it. So go ahead and solve it. Solve that. See what you get for x. I'm calling on one of you. I'm calling on one of you. I'm calling on one of you. Who will I call on? 1, 2, 3, 4, 5, 6. 1, 2, 3. 18, 19, 20, 21, 22. I'm calling on one of you. Calling on one of you. I'm calling one of you. Yeah. Did anyone watch the BTS concert on Saturday night? It was amazing. Midnight, BTS. I love Justin. He's my favorite of the BTS. So handsome. So handsome. Anyway, they're so cool. They're just like got really good personalities. Even though I can't really understand them, I was able to read what they said. Okay, Jasmine, what'd you get for your answer? Hobie, I hear you. Did you watch the concert, Giovanna?
Yeah, I did.
All right. What? Jasmine. Okay, Jay, what's the answer?
I'm working on it right now.
How far did you get, Jay?
Well, I'm just trying to different ways to simplify it.
What? What are you talking about? How far did you get though? That's not answering my question.
I got to x minus 3.
Jay, you talked and you muted yourself.
My baby sister's in the room. She's crying right now.
He's fine. I have kids.
Okay. It's
right all the time.
I got to x minus 3 divided by 2 equals x minus 5, but I'm pretty sure that's wrong.
Okay, look, I did it right here. Jake, don't unmute. Look, Jake,
Yeah.
I'm talking.
They're coming.
Subtract 2x on both sides, right? Jay.
Oh, okay.
Then you get negative x. I add 3 equals negative 7. X equals 7.
Oh, okay.
Do you want me to sing? Do you want me to sing your sister a lullaby? I'll probably put her to sleep.
All right. Thanks.
No, I got you. Don't worry about this. I'm singing to her. Near, far, wherever you are, I will go, and my heart will go on. Oh, oh, Jack, I love you, Jack. Rose, I want you to have a lot of babies. No, Jack, no. I'll have a lot of babies, Jack. I will. Bye, Rose. Oh, he's drowning. I'll stay alive, Jack. I'll have lots of babies, Jack. What movie was that?
I don't know. Titanic.
Yeah, the end of Titanic. Remember Jack and Rose? Actually, you shouldn't watch that movie. There's an inappropriate part that you guys shouldn't watch. But he sinks, and she says, "I'll have babies," and she has babies, and she drops the freaking diamond in the water. Who would do that? I'm telling you. Why would you do that? I'm sorry, I just spoiled the ending. Then
dropped the diamond in the water.
What's that?
Kim Kardashian dropped the diamond in the water.
Does that justify dropping diamonds in water? I'll be happy to take that.
Yeah. Her diamond
What?
fell in the water.
Hey, listen, if you're gonna drop it in the water, I'll take it. I'm telling you. You don't want that diamond, I'll take it. What?
She found it.
She found it or she dropped it?
She dropped it and then she found it.
Oh, she didn't do it on purpose. That's different. Jay.
She was.
Yeah, sorry. My mom was passing through, and yeah.
No, did I listen? Wait, keep your microphone on.
Yeah.
Hey, I put her to sleep. Right? Look at that. See, you didn't want me to do it. Look at everyone here. No crying. I should charge babysitting fees as long as my teaching fees. All right. Okay. Does everyone understand this problem here? Okay, moving on. Did we just do one problem so far? I'm going to erase this in 10 seconds unless someone says they need it. 5, 4, 3, 2, 1. Okay, I'm going to do one more on this section. Then we're going to another section. Okay? I don't know if you guys are learning anything today. Number 11. 11 is 100 5x plus 2 equals 1 over 10, 11 minus x. Okay, take a look at this. What should I make my base? What should I make my base? That's the $1 million question. What should I make my base? Right? Okay, think about it. 100 and 1 over 10. What should the number be? Let's go with Jose. What do you think it should be, Jose?
Yeah. Can you repeat that? The base for
101 over 10. What should the base be? What number? Give me a number.
5, 2.
Ooh, whoa, close, but it has to be higher. This is the hardest part, is finding the base. It's okay if you don't got it. Let's go with Natalia. What should it be? 10. Natalia is 100% correct. 10. Why? Because 100 is 10 to the second. That's 100. Remember, that's raised 5x plus 2. And Jose, what's 1 over 10 with a base of 10?
5.
No.
No.
More.
10.
10 to the what, though?
1.
Less.
0 x. Mind explaining it to me?
It's a number, huh?
Mind
Less
explaining
than
it to me?
Huh?
Mind explaining it to me?
No, I don't do that as a job. You have to figure it out for yourself. It's less than 1, though.
So 0 or
Less than 0.
-1?
Yes, you explain to me why it's -1.
Because the exponent, if you do that, it will turn into 1/10, I'm guessing.
Yes, remember, okay, so look, if I say 5 to the -2, that equals 1 over 5 to the +2, right? The negative exponent does the reciprocal. If I do, if I go 1 over 3 to the -7, that equals 3 to the +7. Negative exponents go like this with the, right? They go like that. Is that, you remember that, Jose?
Yeah, kind of.
But anyway, it does. Does this make sense to you?
Well, so basically they turn into opposites. It changes.
Can I say reciprocals instead of that?
Reciprocals. It changes.
Yeah. So let me ask you this, Jose. What is 5? Not 5. I did that one. What is 3 to the -8? How would you rewrite that as a positive exponent?
1 over 3/8.
1 over 3 raised to the 8th power, right? Is that what you meant?
Yeah.
Okay, cool. What if I say 1 over 7 to the -1? How would I write that as a positive exponent?
7 with 7 to the power of 1.
7 to the power of 1. Very good. Now, let's go with our example there. Hopefully you're understanding this. Hopefully everyone's understanding this. If I say 1 over 25, how would I write that as with a negative exponent?
That would be 25 -1. No, wait.
Cool.
Yeah?
Yeah. How about a base? Yes, that would work. How about with a base of 5? If I'm confusing you, I'll help give you another hint. But with a base of 5. You did
Not sure for that one.
You did a base of 25, right?
Mm-hmm.
What if I wrote it like this? Do these equal?
No. Do they?
Yeah.
No.
What do you read here? What does it say?
That would turn into 5 with the power of -2. So, 5 times 5. Yeah. So it would be 25, right?
So these are equal, yes. And so, yes, this would be 5 to the -2. So I can write 25 as 5 to the -2.
All right. So it's 3 ways to write it, basically.
Well, yeah, but I want you to understand how to write these. Like if I want to make this a base of 5, which remember we have to change our bases for these problems. If this needed to be a 5, well, then you write this as 1 over 5 to the 2 and then 5 to the -2. So for example, if I said this, 5 to the x equals 1 over 25, going with how we're solving these here. Jose, are you with me?
Yeah.
I can write this as, I just want you to know how to use the negative exponents. Right? Now I can solve this, knowing that 25 is 5 raised to the -2 power.
Okay.
Anyway, sorry. Did I make it worse for you? Don't you hate when teachers make it worse? Did I make it worse for you, Jose?
I understand more than before.
All right. Okay. Well, that's good. I'm glad I didn't make it worse. I'm going to erase this for a second. But what makes this the hardest is finding the bases and making them the same, right? So you have to think, well, this is going to be 10, and 10 is 10 over -1. So anyway, this becomes 11 minus x, right? I put that here. This is 1/10, and I just put the exponents where they go. Now I have to multiply these. 10 to the 10x plus 4 equals 10. -1 times this is -11 plus x. Any questions on that step that I did there? Going from here to here. So once you raise it, then you just multiply and get those exponents all together. And then, what's my next step for this, right? Roberto, what's my last step to solve this? Or not the next step, it's not the last step.
You solve the exponents.
Yeah, so how, okay, what do you mean by that? I think I know what you mean, but I don't know if I know what you mean.
You put both of them like 10x plus 4 equals minus 11 plus x.
Very good. Negative 11 plus x. And then you guys can solve that. I'll let you guys solve that on your own. I'm going to move on. I'm going to move on from 11 to 15. Okay, 15 is a crazy problem. Let's look at 15. I'm going to erase this in 10 seconds unless someone says they need it more. So the point is you got to get the same base to solve these problems. That's the hardest part, is finding the same base to solve these problems. 5, 4, 3, 2, 1. Being erased. What number is next? We just did what number was that? 11?
Yeah,
So,
that was 11. We're doing 15.
Look at 15. You guys want to move on, or should I help you with 15? 15 is, can you guys see 15? 3e 4 to the x plus 9 equals 15. This looks crazy because of this e here, okay? Because of the e. That's why it seems hard, but it's, I'd say it's maybe easier than what it seems, but maybe not. That e, and then you have 4x as the exponent, you have this 3 and the 9 and the 15. Okay, so the first thing we want to do is we want to get e by itself. I have e here, I want to get e by itself. So I get rid of the 9 and the 3. Okay, sure enough. 9, take away 9, take away 9. No problemo. 3e 4 to the x equals 15 minus 9 is 6. Now I get rid of the 3 to get the e by itself. What do I do to get rid of the 3? Taylor, how do I get rid of the 3? What do I do? I'm gonna
divide by 3.
Yes, very good, Taylor. Strong work. So e 4 to the x equals 2. Okay, couple things now. It looks a lot better, except this darn e here, this darn e. Remember, e is a number. A couple things here. Let me write it over here on the side. I'm going to show you 4 different things that you need to know in order to solve this. Number 1, you don't really need to know this, but it's nice to know. It's not that important. E is equal to 2.71. It's just a number. Okay, like pi is 3.14. Okay. The other thing you need to know is this. Log with a base of e, or log with a base of 2.71, and it continues. It doesn't stop. It's an irrational number. It goes on forever. Log with a base of e is equal to the natural log. Okay, that's all it is. Right? Jay, are you there? Jay, I think I lost you. Jay.
Sorry, my mom came into the room, that's why.
What's wrong with that? Don't be ashamed of your mom. She's nice. Your poor mom. Jay's mom, I don't mind you there. You're awesome. You raised a great son. Okay. All right. So we understand that log base e is the same as the natural log, okay? That's all you need to know. That's all it is. Okay, that's all it is. Now the other thing we need to know is this. If I take a log over here and I have a base of b, right? And then this also base is a b, and I raise that to the x, right? B raised to the x. Notice both of these are b, b, b. Well, that just equals to x. Remember, we did the inverse log rule. We talked about this on Friday. Log base b to the b to the x is just equal to x. Okay? These two bases are inverses, and it equals x. Okay, now that you know all that, here we go. Watch this. Are you ready? This is crazy. So I'm going to take the natural log. Okay, I'm going to take the natural log. What is natural log again? Let's see, let's see, Jacob. What's natural log again?
It would be.
I said it over here. What's the natural log? You see it? Look here. Don't look here. No, look what I have here. Can you see this?
Kinda.
You can't see it? Huh?
No, I gotta pin your thing. So you want me to insert the numbers for 15?
No. What's natural log equal to? It's right here. What's it equal to? Can you read this or no?
Not really.
Can you read this?
N?
What's this?
Oh, 1N.
Were you paying attention?
Not really.
Okay, fine. Pay attention. Okay, let's go with Donnell. Pay attention, Jacob. What does natural log equal to?
Log base E.
Thank you so much. Jacob, what's natural log equal to?
Log base E.
Awesome. So if this is log base E, and I have a base of E raised 4 to the x power, okay, I just multiplied by natural log. Guys see that? If I multiply by natural log on the left, I get to multiply by natural log on the right to keep it balanced. Okay, you guys with me? I just multiplied by, you don't know why, I'm just telling you can do that. If I multiply by natural log here, I can multiply by natural log here. Okay? You guys with me? Now, this is log base E 4 to the x. Just like this. I'm doing this. If this equals x, what does this equal? Okay? Morella, what do you think? I know you got this, Morella. This is hard, but...
Would it be x? Or
4x? You're so... Yes, 4x. These cancel out, and this becomes 4x equals natural log of 2. The e is now gone because we did the inverse log rule by plugging in the natural log. Jacob, are you still paying attention?
Yes.
All right, very good. So now I have 4x equals the natural log of 2. So basically we just write it like this.
Is that what's on the bottom?
Wait, what?
Right under the natural log EFX.
Can you not see this down here?
No, I can't see that.
Okay, maybe let's scoot it back a bit. Can you see it now?
Give me a second. Not
I
really.
can't. How about if I go down?
There you go.
All right. So it's 4x equals natural log 2, right? Because this cancels out, this becomes 4x. But I still have this natural log here because there's nothing to cancel out. This not has the base of e. The sum base of e, so I have to keep it as natural log 2. I divide by 4 on both sides, and I get x equals natural log 2 divided by 4. Or x equals 2/4, or one. Let's call it 1/2. Where's my eraser? 1/2 the natural log. Okay, I'm moving on. I'm going to erase this in 10 seconds unless someone needs it. Got 19. 19's crazy too. These are crazy problems. Okay, 5, unless someone needs it. 4, 3, 2, 1. I'm erasing it. Goodbye. Goodbye. You are the weakest link. Goodbye. Okay. Let's read number. Can you guys see number 19? Try to open up to number 19. It's a crazy word problem. You need to see what we got here, okay? You're driving on a hot day when your car overheats and stops running. The car overheats at 280 degrees Fahrenheit and can be driven again at 230 degrees Fahrenheit. When it is 80 degrees Fahrenheit outside, that's not that hot. The cooling rate of the car is R equals 0.0058. How long do you have to wait until you can continue driving? Okay. So let's write down what we have. So the car is overheated, right? So let's give everything we have different temperatures. We have the car. We want the temperature to equal. We want it to equal 230 degrees. Okay, we want it to equal that. The car overheats at 280. So we'll say at T of 0, it's at 280 degrees. Okay? Actually, let me stop. We're going to use Newton's law of cooling, which is this. The temperature equals go ahead and write that down. Okay, so this is going to be our target temperature. It's like our target. This is our current temperature. T of 0 is our current temperature. T of R is our outside temperature. So T of R is here twice. And the R is the rate of the temperature change. And the little t is the time. Okay, so we want to, so going back to our problem, we want it to be 230. It's 200, the current temperature is 280 degrees. We want to cool to 230. The outside temperature, we'll call that T of R, is 80 degrees. I know I'm in the way there. I'm out of the way now. And our rate is 0.0058. Okay, so we just plug it in and solve. Okay, so this is Newton's law of cooling. Our temperature we want to hit is 230 degrees. Our temperature that we currently have is 280. The temperature outside is 80 degrees. E, negative. Our rate is 0.058. Have a little t there. There's a t there because that's what we're solving for. We want, and then plus our outside temperature again. So the question is, how long will it take to cool to get to 230 degrees? The t will solve us our time. And we just solve it. Now, of course, our variable is in the exponent. So we know we're going to use logarithms. I also see an e. Which special logarithm are we going to use when I have an e?
Natural log?
Natural log. So let's solve. Look at all this stuff right here. I want to get e by itself. Okay? So let's do 280 minus 80. 230 equals 200 e to the negative 0.0058 plus 80. Okay. What's the next thing I need to do to get e by itself? All right, Brandon, what do I do next? Brandon, can you hear
by itself?
Yeah, what do I get e by itself? I have 200, this decimal, oh, don't forget my t, and this 80.
Would you subtract 80?
Very good. I subtract 80. 230 minus 80 is 150, I believe. Yep. So I got 150 equals 200 e to the negative 0.0058 raised to the t. Okay, still need to get e by itself. What do I do now? E's not by itself. Jeshua, what do you think I do next? I want to get e by itself.
Divide by 200 on both sides.
Nice, very good. Divide by 200. 150 divided by 200 is, let me calculate in my brain real quick, is 0.75. I think it's 0.75. Is that right? Yeah, 0.75. So I got 0.75 equals e to the 0.0058 negative t. Can you see that, Kayla, down there? Or is that... Kayla, can you see that? I know you couldn't see the lower before.
Yes, I can see it. I can see the whole whiteboard now.
Awesome. Okay, so I'm going to erase this stuff above it because I'm running out of room. Actually, maybe I could fit it over here. I'll fit it over here. Fit it over here. There's my little space. I got a little workspace now. Okay, so I have 0.75 equals e to the negative 0.0058 t. Okay, here's the $1 million question. Who remembers how we can get rid of this e with an exponent there? What do we do? We just did it. Gianna, what do you think we do? We did it in the last problem. How do I get rid of the e?
I don't know.
I'll give you a hint. It starts with an N and rhymes with natural log.
Natural log?
Very good. You're so smart. So I want to put the natural log on both sides like I did before, right? Natural log of 0.75 equals the natural log. I'm going to get out of the way of e raised to the negative 0.0058 t. Now, can you guys see that? Since I got the natural log over here, this cancels out the e, and this ends up being natural log of 0.75 equals the natural log e cancels out, and you have this negative 0.0058 t. Because the natural log goes away. Then I divide by negative 0.0058, and that's your answer. And it's, I don't know, it's 0.75. So 0.75 divided by 0.0058. Need a calculator for that one. One. So I got negative 129. Is that, do you guys get that? Negative 129.31. Natural log equals t. So get the natural log of that. You should have your answer. Wait. Hang on a second. Wait, I did something wrong. Oh, shoot. You know what I should have done? Actually, no. You know what I should have done? I should have got the natural log of 0.75 first. So let's do that. Start over. Let's get the natural log of 0.75. Negative natural log of 0.75 is negative 0.288 equals negative 0.0058t divided by negative 0.0058 divided by negative 0.0058 divided by negative 0.0058. They get 49. So it'll take 49.6 minutes for it to cool. And that's the whole problem. Dang. Okay, I'm gonna do the next ones pretty quick. That was a big problem. So make sure you have this equation written down in your notes. Newton's law of cooling. Okay, I'm going to erase this in 10 seconds, unless someone speaks up. 5, 4,
Can
3.
you not see it?
Sure. Wait, what'd you say, Kayla? Just not erase it? Or did you say you can't see it?
I said, can you not erase it?
Yeah, I won't. I got it.
I'm done.
All right, cool. Anyone else? I'm going to erase this in 10 seconds unless someone says something. 9, 8, 7, 6, 5, 4, 3, 2, 1. It's gone. No, all that work. All that work to waste. There you go. Okay. All right. So that was 19. So 21, 23. Okay, look at 23. I'm going to solve this very quickly. This will take less than 2 minutes. So stay caught up. Make sure you're awake. Log 2 3x minus 4 equals log 2 5. Jacob, are you paying attention? Jacob. Yeah. Okay, yeah. Cool. You paying attention?
Yeah.
All right, very good. All right, Roberto. Did you call Apple yet?
Yeah, it turns out I had to update my Mac.
Oh, look, you're there.
Yeah.
All right, very good. You fixed it. Good man. Okay, easy problem. Log 2 times 3x minus 4, log 2 times 5. Just divide by log 2. And it's 3x minus 4 equals 5. And that's all you got to do. Okay? You guys solve that on your own. I'm going to do 23, do 27. I'm doing 27 next. I'm going to erase this in 10 seconds. 9, 8, 7, 6, 5, 4, 3.
Can you hold on?
Yep. Who said that?
Me, Jay.
Okay, Jay. Let me know when you're done, Jay.
All right, I'm done.
All right, I'm erasing it. Okay, next, I'm going to 27. Okay, so log 7, 4x plus 9 equals 2. Okay, real quick, how to solve it? I only have log on one side. This is going to be with this, this is going to be with this rule, okay? This inverse rule. Remember, if I have, so this is in your notes, the inverse, but you don't have to write it down if you want, or you can write it down. It's this rule. If I have a base of b and my exponent is log b to the x, notice I have a base of b and a base of b, then my answer is going to be x. So if I have 8 and I have a log base 8, little 8 to the x, like that, these 8s and log 8s, since this is a base of 8 and this is a log base 8, since these are both 8s, they're inverses and it becomes x. Okay? That's the rule you're going to use. So, knowing that, watch what I do here. Okay, I'm going to erase this. Knowing that, watch what I do here. Because this has a base 7, I'm going to make, just for exaggeration, you don't have to write it big, but I'm going to do a big 7. You don't have to do a big 7 on yours, but just so you know. So you know, big 7, this is my base. And my exponent for this 7 is going to be log 7, 4x plus 9 equals. Okay, so what did I do? I just put a base here. I want to say, I just put a base there, right? If I put a base on the left, what am I going to have to do on the right? Giovanna, what do I have to do on the right?
You're going to have to put the base over there too.
So it's going to be 7. What am I going to raise that 7 to, do you think, Giovanna?
To 2?
Very good. Okay, you guys see that? Now, these cancel out because they're inverses, right? This is my x. Remember I said before, if I said b log b to the x, that becomes x, like that right there. That's what's going to happen here. These are going to cancel out. This ends up being 4x plus 9 equals, what's 7 to the 2? This has nothing to, there's no log base 7 here, so it stays the same, but 7 to the second we know is 49, and you can solve it like that. That's 27. I want to move on. You guys solved it on your own. 27. So 31, you're going to do the same thing. Just raise it to the 2, okay? And that'll become 4. So 20, 31. I think I'm going to do one more, maybe. 33. Okay, I'm going to erase this in 10 seconds. I'm going to do 33. Make sure you guys do the stuff in between, right? This is where you guys have to practice this on your own. You ever have that say, oh, I was able to do this when Sensei's with me, but you guys got to practice these on your own. Sorry, I erased it. Can I erase it?
Is it every other?
Every other odd, yes, but I'm not going to do, see, wait, I did 27. What is next? 31. I'm not doing 31. You guys do 31. I'm doing 33. Every other odd. Did I skip one or something?
Wouldn't it go 31 and 35?
Well, I did 27. Oh, 31? Yeah, 35. Okay, I'll do 35. Sorry. I skipped. So many skipping. Okay, so natural log is just log base e. That's all it is. X plus natural log x plus 3 equals 4. Equals 4. Now our product rule says if our base is the same, we have a base of e, this becomes, you guys ready? And I'm adding, you don't remember? You don't remember? Natural log of x times x plus 3 equals 4. Now, what's my base here again? Gracie, what's my base?
Is it E?
Yeah, E. So I could do the inverse again, and I could put a, you don't have to make it big, but I'll do a big E. That's my base with a natural log base E. Well, that's not, doesn't need to be there. So the natural log has a base of E to the x times x plus 3 equals, oh, if I put an E on the left, sorry, I have to put a big E on the right. Big E to the 4. And this is going to be x times x plus 3 equals e to the 4. I know I'm in the way. Hang on. Need to check something here. That's 35. I know I'm in the way. Be patient with me. Yeah, it's hot. Let me go open a window real quick. I'm really hot. I'll get out of your way. Okay. I'm wondering if I should just do e to the 4th and solve that e, which is 2.7. Yeah, so you just, so basically to solve this, okay, so we have e to the 4th, and I'll let you guys solve the rest on your own, but it's going to look like this. Multiply the left, x squared plus 3x equals e to the 4th. It's a quadratic because it's x squared. I set it equal to 0. X squared plus 3x minus e to the 4th equals 0. Now I think your calculator has an e button. It's above the natural log, so you can use that. Like mine is right. I don't know if you can see mine is my natural log. There's an e above it. I don't know if you guys can see it, but you got to hit the second second function. It's above the natural log. And then 4. And you get 54.59. So you get x squared plus 3x minus, let's see, 54.6 equals 0. Last question before I dismiss you guys. How would you solve for this x right here? How would you solve for that? Actually, before I ask you that, any questions on how I got there?
So we're just solving for E, not X?
No, we're solving for x. Remember, Kayla, e is a number, like pi. E is 2.71. So this is 2.71 raised to the 4th power. So we're still solving for x. E is just a number. So you could put 2.71 there and raise it to the 4th power.
Okay.
But how do I solve for, okay, so no, any other questions on how I got this? $2.718. Okay, you used, remember, let's see. Jaylene.
Yeah.
Who was your math teacher last year?
Miss Schmitz.
Oh, okay. Never mind. She didn't do it, I don't think. Maybe she did. But Donnell, who was your math teacher last year?
Krieger?
Do you guys go sing a song around campus?
No.
Really? I thought he did. Ethan, who was your math teacher last year? Someone answer this question so we can get out of here. Ethan, who was your math teacher last year?
Krieger.
Okay. Who had clay camp?
Me.
All right, Ariana. What song did you guys sing? What song did you sing in clay camp's class when
Can
you
I
walked
sing
around
it?
campus? What?
Can I sing it?
Sure, that'd be great.
X equals negative b plus or minus square root of b squared minus 4. Wait, all over 2a.
Perfect. Pythagorean theorem. Use the Pythagorean theorem to solve this, right? I'll let you guys do it on your own. So solve that. Otherwise, you guys can go. We're over the hour. I wanted to end before an hour, but this ended up being long. It's a hard chapter. We have a test on Wednesday, so we're reviewing the test tomorrow. And next week's our last week for this semester. Then we do finals. Bye, Reggie. Bye, Jacob. Bye, Gianna. Bye, Ethan. Bye, Gracie. Bye, Taylor. Bye, Jasmine. Bye, Joshua. Bye, Jay. Bye, Matthew. Bye, Jose. Bye, Roberto. Brandon. Carlos. Ariana. John. Morella. And bye, Giovanna. And Kayla and Natalia. All right. Let's go with Kayla first.
Are we using, like, I don't know how to.
Is that the Pythagorean theorem? I mean, quadratic formula?
Is that what we're using to solve this?
X equals negative b plus minus square root of b squared minus 4. Is that AC all over 2a? Is that 4AC? I'll write it down for you.
4AC over 2A, yeah.
Yes, you got it. You want me to write it for you, or are you good?
Okay, so we just. Well, how do we know which one's A, which one's B, and which one's C?
Well, I can solve it real quick.
Okay.
Want me to do it?
Yes.
Natalia, let's see what Natalia's question is first. Natalia, what's your question? Are you there? Well, you're really soft. Let me see. Let me turn my volume up. Okay, my volume's all the way up. You got to either speak up.
If we run out of space in our composition book to write, can we just start in a new composition book?
Yeah, no problem.
Okay, that was it.
Yeah, did you use the whole thing up already?
Yeah.
All right. Okay. Yeah. All right, Kayla, I will. So here, remember, this is A, number in front of x squared. This is B, this is C. So A equals 1, B equals 3, and C equals negative 54.6.
Okay, I get it now.
All right, cool. That it?
Yes, I have the whole explanation right here in my notebook.
All right, cool.
Thank you.
All right, I'll see you tomorrow.
Have a good day. Bye.
All right, you too. Okay, bye.